So these are like, what do you call it? What's the word I'm looking for when you make it not so
opaque,
transparent? Yeah, it's not
Translucent.
transparent, but watermark, kind of like anyway. So what we're starting to study is arithmetic. Well, we're starting to study sequences and series, and it's really fun. All right, so sequence. That's what I was saying. I'm going to talk about it as if you haven't ever seen it before, because we don't want to get complacent and go, oh, I know that, because it does help you if you're going to take the ACT. Again, there's more on the ACT than the SAT, but the SAT actually has some sequences and series on it that want you to do some critical thinking that we're going to talk about also. So you'll be glad that we did it, but please don't just go, oh, I got that, okay? There's a lot more to it in a pre-cal book than just what you see on the ACT. Sometimes even the definitions are surprising. I think we tend to interchange the word sequence and series. Like you think of a series of numbers, you think of a series of a sequence of numbers. A sequence is actually a list of numbers separated by a comma. Those appear to have a pattern. It may or may not have a pattern, but they appear to have a pattern. Right now it looks like I'm adding by 2. A series of numbers has a plus sign in it, implying that you're actually going to add them together. So when I can say find the sum of the series. So if I use the word series, all of a sudden you're adding them together, okay? What I just did was I added the first 4 terms together, and we call that the partial sum, okay? So what do you think this means? So I would need to find 2 more and then give the answer. So you see the answer to this is a number. It's a sum, 16. The word series means I'm separating my numbers by a plus sign. I'm starting to add them together, okay? Some interesting things that are coming. There's a way sometimes to add up an infinite amount of numbers. We'll talk about that later. All right, so today we're going to focus mostly on patterns and how you can add up some certain things. And let me grab the book so I'm not just flying blind. If I start making up problems, that's usually not a good thing. All right, so I believe we're in chapter 8. By the way, don't forget, try not to forget your 2 new formulas for area of a triangle, because they work for any triangle. Don't forget that. 1/2 AB sine C means 1/2 of 2 sides and the angle between them. Or the square root if you have all 3 sides of S times S minus A times S minus B times S minus C. It's such an odd time that you learn it in your math career, but they're more useful. You can forget 1/2 base times height and do a lot better than forgetting the other 2. Because it'll only work for right triangle. Okay, so anyway, I gotta have a way to refer to things. So if I have just like it could even be like a willy-nilly list of numbers. This is a sequence. Okay, there's no pattern to it or anything as far as we can tell, and that's okay. But what makes it a sequence of numbers, a sequence is I've separated it by a comma. If it was a series, I would start to add it together. Right now, I have 1, 2, 3, 4, 5, 6 terms. And so if I want to talk to you about it, math is a language. A lot of times, every time that somebody moves here from another country, or we have exchange students, they can pick up the math class pretty well because it's really a universal language. But anyway, I have so many things that I can do, like I can do this. And that says, what did you square to get 16? It's an entire sentence in a symbol, okay? So I want a way to talk about these so that I don't go, hey Ava, what's the 5th term? I can just go, A sub 5 is what? Well, let's talk about why they decided on this nomenclature. Like, why are they signifying it this way? It's a quick way to say the 5th term, but I don't want to put 5 in the air because it's like 8 is 5th. I don't want to put 5 next to it because that implies to a mathematician that you're multiplying them. And so we use this subscript, just to identify terms. And so you have these A sub n's. A sub n actually means any term. And then once I go put in something for n like A sub 3, I'm talking about 5 in this case. So a sub 1 in this case is 1. What's a sub 5?
2.
A sub 5 is 2. Okay? And a sub 5 also equals a sub 2 only in this sequence because they're both 2. So do you see how I can refer to a sequence? And so now I might say, I want you to find a sub 15, which in this one I can't, but that's coming. Okay? All right. So now, well, I guess I can do it up here. All right, so now let me show you a couple of things that we're gonna do. So you'll be given sometimes a definition. Like here's one, a sub n is equal to 3n minus 2. That would be like me walking up to Nazareth and saying, okay, so Nazareth, you can find any term by saying 3 times the number of the term minus 2. So look at where the n's are. So let's list the first, let's find the third term, just for argument's sake. This is telling me what's the number of the term. If I have a sub 3, do you see a 3 goes right here?
Yeah.
So I get 3 times 3, like where it is in the sequence. That's me telling you where it is in the sequence. So I get 7. All right, let's list the first 4 terms. You'll have this on homework. Sometimes they ask for the first 5, so let's do the first 5 terms. So a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. All right, a sub 1 is 3 times 1 minus 2, so it's 1. A sub 2 is 3 times 2 minus 2, which is going to be, did I do that right? Yes.
Yeah.
So that's 6 minus 2, which is 4. A sub 3 is 7. A sub 4 is 3 times the number of the term minus 2. So that gives me 12 minus 2 is 10. You could probably predict what a sub 5 is going to be. 13. So what did you notice?
Oh, it's in intervals of 3.
Okay, did y'all see it's adding 3 every time?
Mm-hmm.
All right, if you're adding 3 every time, that's called an arithmetic sequence. It's kind of funny that it's the word arithmetic, but all of a sudden we say arithmetic if we're studying sequences and series. Guess it sounds fancier, I don't know. Hey girls, on arithmetic sequences you're doing what? On Nazareth notice you're adding the same thing every time. And if you notice a pattern, you can kind of go a little bit faster. All right, we're also going to study later a geometric sequence. And that's when you're multiplying every time.
Oh, we did this last year like a little bit.
You've done it a little bit, yeah. That means you're multiplying by the same number every time. So arithmetic, I'm trying to do this like little acrostic so you remember arithmetic is add. It's like arithmetic. And geometric, you have geometric means and all that kind of stuff in geometry, and you're multiplying by the same number. But I thought in Algebra 2, when I encountered it in Algebra 2, I thought, well, there's only arithmetic and geometric, and a lot of times that's what you see on ACT, but on SAT, many times I'm like, oh, wait, that's not either one. So a lot of critical thinking that really goes in with real sequences and series that people use out there a lot in the real world and that we'll use here in this class. There's a Fibonacci series. Fibonacci series is really cute, but it's not arithmetic or geometric. Fibonacci goes like this. It starts with 1, 1, and then 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 and 8 is 13, and it keeps going like that. This is actually called a recursive formula. And I'll come back to that word, whereas this is called explicit, and I'll explain that in just a minute. But I don't know if anybody's ever seen there's Vi Hart that a lot of teachers used to show her videos where she talks really fast and draws. Did y'all see those in middle school?
Oh, yeah, I know what you're talking about.
Anyway, she has a great video that we're not going to look at right now, probably, where the Fibonacci numbers are amazing. Like Fibonacci came up with this sequence, and then when people started, like hundreds of years ago, and when people started looking at nature and applied mathematics, things in nature adhere to the Fibonacci series. So let me show you some.
Oh, the spiral.
Yeah, like the spirals.
Were you in Miss Bear's Skinner's math class?
She was at Mary
Radar. In Miss Bear's Skinner's math class, we just like look at pictures and then draw swirls and be like,
I saw her in the
Fibonacci.
lobby the other day.
I always see her sometimes.
Is she still working here? I don't know.
Me neither.
Maybe she's interviewing because she was 6 later. Who?
Oh, Miss Baraskina?
Yeah.
She's in the lower mid.
Oh, she does work here?
Yeah, she's been here. Yeah,
Noted.
she's always here. Yeah, she's at 82nd
I love
Street.
her. She's so sweet.
Yeah, she's awesome. I was her for 3 months. I was
Oh,
Miss
yeah.
Paraskina for 3
In
months.
5th grade,
I remember that too.
Wait, does Miss Beta
Caitlin's
still-
hand was in that.
She's in
backpack.
So was
Turkey.
Carl.
We
That was
were
like
the
the smart
freshmen,
people.
And then they'd be like, time for the kids to go, and they'd go upstairs and do math.
Yeah, you're right.
So there's all these images.
Maybe that was the first time I ever did algebra. We were like, none of this makes sense.
Remember you turned in your homework with tears? The long division one was like
Yeah,
wet.
she'd be like,
She's like, why can't I read this? You're like, I cried on it actually.
I really did not like her.
So here's Fibonacci. 11 he lived in the 1100s.
Actually, no, he looked.
And they have found here.
A little bit.
Let's go ahead and do this.
But I feel like he looks so small.
Kepler.
Let's see. Well, that's not what I
I just remember
wanted.
one time she showed us a picture of a fire
Same.
hydrant.
Oh, sure.
Wait, what happened?
No, there's a
I saw that.
dog, and I got it.
My brother and dad saw your dog in the park and they kept talking about it. They were like, it's so cute.
I want a baby swan.
All right, we'll watch this
I
a
want a
bit.
big, you know what's so cute? I saw
Dinosaurs
yesterday.
are cute.
All right, girls.
Seals.
Wait, hang on.
They're just so precious.
They definitely smell bad.
Have you ever
Seals?
seen one
Yeah, because they're
I've
literally
been-
like hunks of leather.
though? Cute.
And they eat
When I
like
look at one, I
raw
want to
fish.
cry.
Like
This is
innards.
Ari.
Hang on, I got to get the sound done.
Yeah, it's
Well,
lovely.
who knows what the teacher's talking
Okay.
Oh, I remember this.
What?
I remember.
Oh my gosh, just uncovered.
You've
a
probably
memory
seen
that I
it.
never
It's
knew I
pretty
had.
common.
I don't
Hang
As
on.
well.
Greenhouse number 3. Plants.
This was a homework. of
Anyway,
ours.
we've decided there's 3 basic types of spirals. There's the kind where as you spiral out, you keep the same distance, or you could start big but make it tighter and tighter as you go around, in which case the spiral ends. Or you could start tight but make the spiral bigger as you go out. The first kind is good if you really want to fill up a page with lines, or if you want to draw curled up snakes. You can start with a wonky shape to spiral around, but you've noticed that as you spiral out, it gets rounder and rounder. Probably something to do with how the ratio between 2 different numbers approaches one as you repeatedly add the same number to both. But you can bring the wonk back by exaggerating the bumps, and it gets all optical illusion-y. Anyway, you're not sure what the second kind of spiral is good for, but I guess it's a good way to draw snuggled up slug cats, which are a species you've invented just to keep this kind of spiral from feeling useless. This third spiral, however, is good for all sorts of things. You could draw a snail or a nautilus shell, an elephant with a curled up trunk, the horns of a sheep, a fern frond, a cochlea, and an inner ear diagram, an ear itself. Those other spirals can't help but be jealous of this clearly superior kind of spiral. Better draw more slug cats. Here's one way to draw a really perfect spiral. Start with one square and draw another next
All
Oh,
right,
Oh,
uh,
Oh,
watch,
um,
watch, watch.
Make the next square fit next to both together,
me
that is,
pause.
each side is length 2. The next square
All right, so far she's doing on graph paper what I just had on the board a second ago. I had a 1 and a 1. I added those and I got 2.
Mhm.
And then I added the 1 and the 2 and I got 3.
48.
And so then the 2 and the 3 add and get 5. So she's actually doing it on graph paper. But watch what happens, because you should wonder, even I know you maybe saw this in a long time ago, but it probably wasn't registering the way I want it to now. She's been drawing spirals, and you're like, okay, so who cares? What does that have to do with what Miss Lazari just showed me with Fibonacci numbers? So let's be quiet now and just watch, okay?
has length 3. The entire outside shape will always be a rectangle. Keep spiraling around, adding bigger and bigger squares. This one has side length 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and now 21. Once you do that, you can add a curve going through each square, arcing from one corner to the
All
other.
right, so if you look at it, that was 1 and 1 gave us a sides of 2. And then 1 and 2 gave us sides of 3. And then 2 and 3 gave us this square, which is a side of 5. And then if you add 5 across to this 3 right here, you get 8. The Fibonacci numbers always go 1, 1, 2, 3, 5, 8, 13, 21. But she's showing you on a piece of graph paper, so keep watching. It's so fascinating how math is embedded in nature in a somewhat irrational way.
Next to corner. Resist the urge to zip quickly across the diagonal if you want a nice smooth spiral.
Yeah, it makes
Have
a
you ever
spiral.
looked at the spirally pattern on a pine cone and thought, hey, sure are spirals on this pine cone? I don't know why there's pine cones in your greenhouse. Maybe the greenhouse is in a forest. Anyway, there's spirals, and there's not just one either. There's 1, 2, 3, 4, 5, 6, 7, 8 going this way. Or you
Listen,
could look at the
listen.
spirals going the other way, and
Listen.
there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Look familiar? 8 and 13 are both numbers in the Fibonacci series. That's the one where you start by adding 1 and 1 to get 2, then 1 and 2 to get 3, 2 and 3 to get 5, 3 plus 5 is 8, 5 plus 8 is 13, and so on. Some people think that instead of starting with 1 plus 1, you should start with 0 and 1. 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, and it continues on the same way as starting with 1 and 1. Or I guess you could start with 1 plus 0, and that would work too. Or why not go back one more to negative 1, and so on. Anyway, if you're into the Fibonacci series, you probably have a bunch memorized. I mean, you've gotta know 1, 1, 2, 3, 5. Finish off the single digits with 8, and ooh, 13, how spooky. And once you're memorizing double digits, you might as well know 21, 34, 55, 89, so that whenever someone turns a Fibonacci number, you can say, happy Fib birthday. And then, if you're interested in 34, 233, 377, but 610 breaks that pattern, so you better know that one too. And oh my goodness, 987 is a neat number, and well, you see how these things get out of hand. Anyway, 'tis the season for decorative scented pine cones, and if you're putting glitter glue spirals on your pine cones during math class, you might notice that the number of spirals are 5 and 8, or 3 and 5, or 3 and 5 again, 5 and 8. This one was 8 and 13, and one Fibonacci pine cone is one thing, but all of them? What is up with that? This pine cone has this wumpy weird part. Maybe that messes it up. Let's count the top. 5 and 8. Now let's check out the bottom. 8 and 13. If you wanted to draw a mathematically realistic pine cone, you might start by drawing 5 spirals one way and 8 going the other. I'm going to mark out starting and ending points for my spirals first as a guide, and then draw the arms, 8 one way and 5 the other. Now I can fill in the little pine coney things. So there's Fibonacci numbers in pine cones, but are there Fibonacci numbers in other things that start with pine? Let's count the spirals on this thing. 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The leaves are hard to keep track of, but they're in spirals too, of Fibonacci numbers. What if we looked at these really tight spirals going almost straight up? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. A Fibonacci number. Can we find a third spiral on this pine cone? Sure, go down like this. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. But that's only a couple examples. How about this thing I found on the side of the road? I don't know what it is. It probably starts with pine though. 5.
No, she doesn't know anything about the property.
I think this is a flower. It's got 13 and 21. These daisies are hard to count, but they have 21 and 34. Now let's bring in the big guns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15,
Seriously
16,
though, it's amazing to
but
look
no,
at
no, it
what's.
is right.
I just
found
found
it.
Every time she
Wow.
counts, she's gonna get a
1,
Fibonacci
2, 3,
number.
4, 5, 6, 7, 8, 9,
I mean,
10,
you can
11,
just pick
12,
up
13,
anything.
42, 53,
Can do it this fast.
4, 55.
55's
I
a
promise this is a
Fibonacci.
random flower and I didn't pick it out especially to trick you into thinking there's Fibonacci numbers and things, but you should really count for yourself next time you see something spirally. There's even Fibonacci numbers in how the leaves are arranged on this
This
stalk.
was what
or
was
this
so
one, Or the
interesting.
Brussels sprouts on this stalk are beautiful, delicious 3 and 5. Fibonacci is even in the arrangement of the petals on this rose, and some flowers have shown Fibonacci numbers as high as 144.
So if you
It
pick up
seems
a
pretty cosmic and
rose
wondrous, but the cool thing about the Fibonacci series and spiral is not
or a flower, and you more slowly obviously counted it yourself, it'd probably start with 3, the next one would be 5, the next one would be 8, the next one would be 13. It's so weird. And it's over and over and over again in nature. A part of it is how it catches the sun by the way that they're spaced. Like if you think of 3 petals and then 5 petals and then 8 petals. But it's all over the place, these Fibonacci numbers. So they're really cool, but I can't really notice a pattern other than I add them together and get to them. And Fibonacci's the one that first really dealt with it that we know of. So let me talk about recursive and explicit formulas. All right, so that we know what those are. All right, a lot of times in our world, explicit means you shouldn't watch it. But there's also explicit just means I'm very clear. I've explicitly told you what I want you to do. I could go, I sure am hot in here, which I'm not. But I could go, I sure am hot in here, and y'all are all sitting there looking at me. So I guess I've implied that I want somebody to open the window or do something about it. As opposed to if I said,
That's
Ava,
implicit.
open the window. Do you see that's, I explicitly told Ava what I wanted to do. I didn't imply what I wanted to do. And in math, you'll even in calculus, those of you that take calculus, most of you will, you'll use something called implicit differentiation. And it'll be sort of embedded in there like, it's very much like if you have a friend or a boyfriend, this can even happen with a boyfriend. It can probably happen with a girlfriend too, but sometimes I find it a little more gender specific where you're trying to tell somebody something And the guy is quite often going, why don't you just say what you mean to me? You know, I could go, I sure do like sapphires. I sure do love sapphires and implying that I want a sapphire engagement ring, okay? Or I can just go, I want a sapphire engagement, because they could go, why didn't you tell me that's what you want, you know? So do you see the difference in implying? I'd rather somebody just tell me what they mean. So, anyway, that's explicit and implicit in mathematics. Now, I tell you what, let me play a little game with y'all. There's some days in here that you actually, I think you're aware of by March, that you actually teach yourselves. It was really exciting to watch you figure out when I asked you, first of all, things like this. I don't know if you remember the day I just sort of sat back and let you run with it. Because of course, then you pushed inverse sine on your calculators where you're talking to your friend. But then you realize, wait, but sounds positive in the second quadrant, and there's more answers, and you sort of, I'll let you set the stage for what I was gonna teach you, all the way up through law of sines. So anyway, kind of teach yourself this. Get out some scratch paper, okay? Or jump up to a board, but I've got a few markers, just get some scratch paper for now. Alright, so I'm gonna make up arithmetic sequence. So let me make up an arithmetic sequence. Oh, by the way, the common difference right now is 6. We call it D. That's a common difference. Do y'all see the difference in the numbers is 6? If it was going down, my difference would be negative something. Okay, so you always talk in terms of what you're adding. So if you want it to go down, you've got to add a negative. All right? So here's your job. I want you to find this. And let me find it so I'll know if you got it right. How could I have 41 text messages? Oh my gosh. My running group of friends goes nuts. I guess. Everybody, don't you, I wanna
Really
go,
makes you
I
want.
wanna go, don't y'all work? Like, do you have something to do?
Does that mean you add them all together, or is that asking for that?
I want the 200th term.
Can I ask you if this is right?
Do you have an answer?
I have a guess.
Okay, what do you have?
12,004.
Let me make sure I did it right. I got a different number. I got my same number both times. Do you have an answer, Nazareth?
Yeah.
You can use your calculator if you'd like, or your phone. You should have your calculator with you.
12,098.
That's closer-ish. I think it's maybe just, since you're doing it by
Is this
hand.
in a Fibonacci?
Oh, this is not, no, this is not a Fibonacci sequence. Fibonacci's always 1, 1, 2, 3, 5, 13, 8, 13. This is an arithmetic sequence. Okay.
Is it 2,600?
What did you say, Nazareth? I said 1298. I got 300.
Nope. I see this. I got 806, so I actually could go with them. My calculations seem to be
We'll
incorrect.
stand here till y'all get it.
24.
Girls, hopefully you won't have time to just find, hopefully you'll find a quick way to find the 200th term. We will not sit here until you keep adding 6
Yeah.
to or out to the 200th term. Find a quick way to find
That's
it.
what I'm trying to figure out, but I have no idea how to do that.
I keep getting the same.
It's 1633.
1198.
1198.
How'd you get that?
All right, how'd you get that?
So I took,
Yay, Nazareth.
I did 6
Listen to what what she did. She figured out a
199.
mathematical formula. Go.
I did 6 times 199. And then, which I got 194. And then I added 4 to that, since that's the first term.
I did 6 times 200, that's how I got 1204. I just realized that when you said it, you have to do 199
Okay.
times 200.
Because, how is Nazareth, girls, now stop. No, stop. Stop. We're gonna talk about what Nazareth just explained to us. How would you get to the second term? Nazareth would start with 4, and she would add what 2 times?
6.
Okay, Nazareth had the luxury of already having the first term, so she didn't need to add 200 more 6s. If Nazareth already has the first term, to get the third term, how many 6s do I add? 2 6s. To get the fourth term, how many 6s do I add? Isn't that 4 plus 6 plus 6 plus 6?
Would you say
Okay,
4 plus
so actually I could ask you any number of term, couldn't you? When you start with 4, and if I want the 2000th term, are you gonna add 2,000 6s?
No.
How many 6s? 1,999 because you already have the first term. So she needed 199 more blanks past the fourth one, right? Past the first one, which was 4. All right, so let me give y'all one and see if you know Nazareth's formula. We could name it Nazareth's formula, kind of like the Fibonacci sequence, okay? But y'all, it sounds like a lot of y'all were on the same track. So let's say if I have,
That's such a scary sound.
I don't want to use that. All right. Okay, so let's find the 43rd term.
The 40 what? Sorry. Oh, it says right there.
Yeah.
One, two, 6,
Almost.
121.
121. So Julia, you're
Why
doing
can't I
something and you're forgetting that you already have the first term, I think.
Wait, what is it?
You do.
Do you have an answer on it?
Yeah, but I got 124.
121.
Oh.
Alright, so let's logically think about it. I'm gonna start at -5. Watch my pen. I'm gonna start at -5 and add how many whats? What am I adding first of all? How many? I'm adding 3, +3, that is important. This one's going up. How many of them?
42.
42. I'm gonna add 42 3s. Do y'all understand why? I'm at -5, and this is my second term, third term, fourth term, fifth term. Let's stop at a sub 5. If I add 3, I get -2. If I add 3, I get 1. If I add 3, I get 4. If I add 3, I get 7. So I started at -5, and I added how many 3s? To get to the fifth term. Girls, common sense would tell me if I want to get to the fifth term and I already have the first term, how many do I have to go? If I already have the first term and I want to get to, I only have to go 4 of those 3s. 4 times 3 is 12. Okay? So try this one. Let's use the same sequence. It's called a sequence. It's separated by commas. So find this one.
Sequence.
A sub 20.
For the same sequence.
Same sequence. See if more of you can get it this time. You're all around it. See if you can get it.
52.
52. Okay? So, Julia, did you take the first term and add 19 threes?
Yeah.
Okay?
Oh,
And does that make, hopefully girls, that makes perfect sense.
Yeah.
I'm not trying to get you to memorize anything right now. That should make perfect sense. Okay? Now let me give you kind of a tricky
Oh, I
one,
got
okay?
52 also.
Okay, y'all ready? Alright, now, I'm gonna give you somewhere in the middle. I'm not gonna start at the first term, I'm gonna start at the third term with a number like 4. And then, I'm gonna give you the 20th term. Let's see. Is 38, and I want you to find the 5th term. Use common sense.
38 is the,
It's the 20th term.
okay.
Wait, what term?
The 5th term.
Find the 5th term?
That's your job with those 2 clues, is to find the 5th term.
Okay, I got it, but I don't know if it's right. Actually,
What'd you
just
get?
kidding. No, I said 8.
8 is right. 8 is right. That's awesome. That's tough.
How'd you get that?
Okay. If I taught you formulas first, I think you would have a harder time. But if you use common sense, I'll back it up with a formula. Okay? But I prefer that you not use the formula, that you use common sense. Anya, do you remember what you did?
Yeah.
Okay.
So basically, I tried to see, like, so it's a to the 3rd or like a to the 20th. So I tried to see like 3's relationship to 4 and 20's relationship to 38. So then I don't know how I like kind of like messed around with the numbers. And 3 times 2 minus 2 is 4, and 20 times 2 minus 2 is 38. So I like called it x or whatever. So x times 2 minus 2 gets the number. So 5 times 2 minus 2 is 8.
Whoa. Okay. Say that again. let me write that in red. Okay, what?
Okay. So I found out the relationship between 3. Do I just say the whole thing? Or gonna
Between
just
3 and 4?
Yeah, between 3 and 4, and
Alright.
like what 3 and 4 had in common with 20 and 38. So I
Okay.
found out that 3 times 2 minus 2 gets me 4, and 20 times 2 minus 2 gets me 38. So then 5 times 2 minus 2 is 8.
Cool. I don't even know what's embedded in that. That's really cool. So this is 3 times 2 minus 2 was 4. So I don't know how often that would work. I could try that, and when I go to some other ones.
Okay.
There's something awesome embedded in that. I'm not sure what it is. That's super cool. I've never seen anybody do that. I love that.
It was a good guess and check.
Okay. I guess that's the danger, is if it was
Yeah.
some weird number, because our difference might be 2.3.
Yeah.
And, but there's probably a lot more intuition in that than you realize. Anybody else get 8?
I got 9.
Okay. Here's what I would do, that I thought you would do, but now Anya's got us thinking about this super cool thing. Alright, this is what I thought you would do.
They're supposed to try to find a pattern from.
Okay, wouldn't y'all agree that the dilemma is you have no idea what your difference is? Okay? Here's what I thought to myself. I thought, well, I started at 4, and somehow I got to 38, okay? By adding something, how many times? I thought to myself, I started at 4, I had to add something to get to the 20th term, which I know. But I didn't start you at the first term, so it was a little bit harder. From the first term to the 20th term, girls, wouldn't you have to add 19? All right, let's watch this. From the first term to the 20th term, if you start at the first term, you would have to add 19 D's. Why 19 and not 20? Because you already have the first term. To get from the first term to the 5th term, how many D's do you add?
Wait, are we using this -5 and -2? 1 4.
No, I'm just pointing at this right now, okay? So let me erase this.
Sorry.
So I'll just write some bare bones facts up here without numbers, so it doesn't get confusing. So if I'm at the first term, and Nazareth wanted to go to the 200th term, she started at the first term that I gave her and added how many?
199.
199. All right, if I started you at the first term and wanted you to go to the 43rd term, how many differences did you add? Do you remember? Or what makes common sense? I already gave you the first term, so how many more do you need? To get to the 43rd term?
Oh,
42.
42?
To get to the 43rd term?
Yeah.
Okay, so look up here. You need to look up here to actually see what I'm doing with this. So how would you get from the first term to the second term?
One more term.
One more term. So how are you gonna get from the one I just asked, the third term to the 20th term?
3 minus 20, 17.
17. Did y'all notice this was 199? This was 42. 2 minus 1 was 1. So we needed to go 17 more of those. Did y'all see that? So if I start at 3 and I want to get to 20,
Yeah.
I've got 17 of those unknown quantities. And so what I did was I did this, because I just made it up off the top of my head. I had to work it also. So I said, okay, I started at 4. Sorry.
That's 16 by X.
I started at 4. I added something to get to 38. And how many times did I add that? I added it 17 times. Okay? So to break it down a little more, how are you going to get from the 3rd term to the 5th term? You're going to add D 2 times. Okay? So let me give you one, then I'll give you the formula. All right, so try this one. Let's say if I have A sub 5 is 10 and A sub 15 is 300. Let's find the first term. And it may be ugly. I didn't put much thought into this one.
I can use my board for this one.
I think it's gonna be really ugly, so let me change, just so you can like have numbers you can work with. Hang on.
Really?
No, I think we're good. Okay. I think we're good. Okay, I have a number.
Is it like a weird number though? It's like a.
I got a whole number. Did you get a whole number or did you get a fraction
Oh,
decimal?
it's a whole number. It's just like.
It's a negative.
Yeah.
What'd you get? Anybody? Y'all can all do it. It's common sense. You can do it. I don't have any common sense. If I can do it, you can do it. I'm guessing y'all have a lot more common sense than I do. I think I got a whole number. Maybe I didn't because y'all were struggling with it. Let's work it together.
Sure, I got a whole number, but I'm not sure how many times if I subtract.
Well, what's your number? Let's see if ours is the same.
I
Unless you
got,
just,
at first I got negative 77 and then negative 106.
I got negative 106. Okay, so I guess that's right. So the first term I think is negative 106. All right, what I mean I think is we're just typing things into my phone. All right, y'all watch, common sense. I'm gonna start at 5. I'm gonna add something, how many times to get to 300? If I'm gonna start at the 5th term, A sub 5, how many times do I have to add something to get to the 15th term? What's 15 minus
I'm
5?
just kidding, 15 minus 5?
I only have to add it 10 times, right? Do y'all see what I mean? Remember how, girls watch, how are you gonna get from the first term to the 8th term? Don't you have to add 7 times? So to get from the 15th, from the 5th term, you need 10 of these. Was this, 300? Okay. Oh, I'm sorry, I'm gonna write it again, excuse me, I wrote that down wrong if you were copying. The 5th term is 10. Then I added some amount of the common difference and I arrived at 300. Do y'all see the common sense? I'm starting here at the 5th term and I'm gonna just start adding something until I get to where I tell you. So I'm gonna get to the 15th term, and how many of them I'm gonna add? 15 minus 5 is 10 terms. So Nazareth and I got 10D equals 290, and the common difference was 29. Now how in the world are we
Oh, I
gonna
got
find?
that.
Good.
But I thought it was wrong because it was
No.
higher than A sub 5.
Well, you're finding your difference.
Yeah, I
You're
realize
finding what you're adding by. Now, what's the easiest way to backtrack to A sub 1? You can start at A sub 5, and you can subtract how many of those 29s? 4. And I think that gives you negative 106. Okay? Do y'all see if I'm at A sub 5? Here's A sub 5. If I'm at A sub 5, I'm gonna go back by 29. I'm gonna subtract 4 29s.
Wait, why is the 10D though? Just because A sub 5 is 10? Or?
Okay, let's do it again, Ava. All right, I'm starting at the number that I was given, which is
Yeah.
10.
Yeah.
I know it's the 5th term.
Yes.
I don't know what I'm adding by to reach 300.
Yeah.
But how many times do I have to add to get from 5 to 15?
Okay, that's what it's
10 times.
Okay.
So those were 2 different 10s, okay? All right, so hopefully you could do any of those. I am gonna give you the formula, but I'm not really pushing the formula. Why don't you help me derive the formula, okay? If you're at A sub 1, and you wanna get out to any term A sub n on an arithmetic sequence where you have the common difference. To get to that last term, or whatever term I'm asking for, you're gonna have to start at the first term. You're gonna have to add D how many times?
The difference of the two.
If I'm trying to get from 1, yes.
1 minus n.
N minus 1. Very good, Kate. That's where most teachers start and go, hello, here's the formula for arithmetic sequences. And then people just learn the formula and they don't have any idea the common sense behind what they're doing. And what happens if you forget the formula?
Stuck.
Right, you're not stuck. You don't have, I think you'll use the formula some, but y'all just did it all without knowing the formula, okay? All right, now, 2 more things before you go. I'm keeping an eye at 135. Let me show you a couple of things of how to write a pattern. Like if I'm going 3 plus 2 is 5, plus 2 is 7, plus 2 is 9, plus 2 is 11. That one is arithmetic because I'm adding 2 each time, okay? So a quick way to write a formula for any term in the sequence, you could use your formula, or you could do this. If you're adding by 2 each time, you can have a 2n in there. I know that you maybe expected me to go plus 2 instead of times 2, like maybe n plus 2. But girls, what's 2 times 1?
2,
2 times 2,
4,
right? 2 times 3,
6,
2 times 4.
8,
All right, so my first term is 2, second term is 4, third term is 6, my fourth term is 8. What's the difference in these?
1.
So my formula is 2n plus 1. You just kind of rig it up and you engineer it to make it work. So let's do this one. Let's go 6, 9, 12, 15, and on and on. All right, let's write a formula for any term of this sequence. First of all, what is it skipping by?
3.
So you're gonna say 3n. What's 3 times 2? I'm sorry, 3 times 1
3.
for my first term. 3 times 1 is 3. For my second term, 3 times 2 is 6. For my third term, 3 times 3 is 9. That's not working But what's the difference in all of these? So it's gonna be 3n, what?
Plus 3.
Plus 3. So you're all of a sudden entering this like creative part of mathematics where you're engineering things, you're creating them, okay? If you're multiplying by something, we'll pick up there when we come back for wherever we go and wherever we've been, alright? So, I haven't decided if I'm doing bookwork or Delta Math, but should matter to you, I will post homework for March 30th. Happy spring break, the longest spring break ever.
Well, longer spring break with France and Spain, technically.
No.
Because we got like